Alright, here we are at 5.2, and just like I promised, we do have now our full A, B, C, and D to deal with. We did our A and our B already. A again for amplitude, where the absolute value of A is the amplitude. B is involved with period. Period is going to be equal to 2 pi over B. And I don't think it's going to be too much of a surprise what C and D are. C shifts it left and right, and D up and down. So in the past, we just called C a horizontal translation, and we can still call it that. Horizontal translation. But you'll see the textbook and you'll see other sources refer to this as a phase shift when we're talking about waves and sinusoidal waves. So we'll investigate that in just 1 second using our happy desmos.com, and D is going to be our vertical translation. So that will be the up and down. And it works just like you're used to from your other transformations that we've studied earlier this term. So let's go take a look at Desmos for a second. And I set up, and it really didn't take me too long, a generic f of x is equal to a sine b x minus c. And you'll see right away we can play around. We already did this before. If we play around with a, then we get that amplitude changing. If we play changing with b, as we make b larger, it gets compressed horizontally, which changes our period. Let's just set this to 2 for a second here. Now an entire period only takes up to pi instead of to 2 pi. Maybe I'll put that back to 1. Now let's investigate what C does. So C shifts it left and right. Okay. Now one thing is, because it's periodic, because it repeats, if I shift this over, I think this is as a decimal, it's not in terms of pi, but I'll try to make C fairly close to pi, so I'll move it over to about 3.14, there, 3.1, and you'll see it looks just like when we started. So if this was my original, I can actually make it look, I'll try to make it 2 pi. There, it pretty well looks the same as before. So I'll put this back to 0. In fact, I'll generate a second one, so underneath it's in red, and when I move this one over, if I make this further over, I can actually make it right over top. So one thing you'll notice is that depending on how we play around with C and D, especially, we can have more than one function that looks exactly the same. So if I go, in this case, if I go positive 2 pi, or if I went negative 2 pi, I think I can go, there you go. If I go negative 2 pi, 6.28, I get about the same answer. So I'll put this back to 0 here. D moves it up and down. There you go. So that will change things like that. And now, what happens if I say make this one cos? Okay, so my black one is in cos and the red one is in sine. I mentioned before that really the difference between the two is just a translation, isn't it? So if I take my sine, and if I would like to move my red one left to make it match the black one, so I want to make this a negative value. So there we go. I made it pretty well there. So that's about half of pi. Negative 1.57 is half of pi. So that's a neat way to do it. Let me show you also what happens when I make a negative. Here, I'll get rid of that cos thing. If I get a is negative, there I get that reflection. So I'll just back up. So the reflection across the x-axis, boom, that's what that looks like. Okay. We don't, quite often we get A as a negative value. We don't get B as a negative value very often, but let me just play with that one. If I make this one negative, you'll see it kind of looks exactly the same as what I just did, but in reality what it is, it's reflecting across the x-axis. So this point ends up over there, and this here, this minimum reflected and came over there. So in fact, in this situation, but not every situation, when I put a negative in front of the B, it actually has the same situation as the negative in front of the A. Okay. All this is to say is that when you're given a graph and you need to make an equation out of it, there is certainly more than one way to make the same equation. And the reason why, the other thing I wanted to mention is the reason why this is called phase shift is, if you remember from our from physics and things like that. We can talk about two waves. These two waves right now are out of phase, and then these two waves are in phase. Okay, and just to do, I could do a real quick thing here. If I said y is equal to my first one plus g of x, if I add the two together and show that one and show it, so this is the purple one. Now as I change the phase of the two, the purple is the sum of the first two. So when they're in phase like this, they combine together to make a wave with double the amplitude, and when they are out of phase, then they cancel each other. So this is how things like noise cancelling headphones work, is where the headphones themselves make the same sound as is coming to the ear, same as the ambient sound, but completely out of phase, so that it cancels out and you get a silence, you get a nothing in the background. Let's go back to our lesson though. Right, so let's get started in this question, and you'll notice first of all I changed a little bit from your worksheet. Instead of having 2 pi over 3, I'm going to get rid of the 2 pi over 3. I'm going to change it into a pi over 2. It's just the fractions work out just a little bit more friendly if we do it this way. So the first step, if you are given the question, sketch the graph y equals 3 times the sine of 2x minus pi over 2 plus 2, we need to factor it, because although it looks like it's in this form, it's not quite. You'll notice that the b has to sit outside of these brackets. So the problem is about this 2x business here. So this is the before picture, and here this is the after picture. This is the way we do want it. So what happened here? We factored out a 2. Right? So when we factored out a 2, we had to divide this term by 2, and we got x, and we had to divide our pi over 2 by 2, and so we got pi over 4. So just as a reminder, if you had something like 2x plus 4, and if you factor out the 2, we get x plus 2. Right? That one's pretty easy to see. This one was more like, what if we had, I'll switch to green here, what if we had 2x minus a half? And if we're factoring out a 2, this would be x minus, what is a half divided by 2? It's going to be a quarter. So this is the example. So even if this is not divisible by 2, nicely, we can still divide by 2. So 1/2 divided by 2, 1/2 divided by 2 is the same thing as 1/2 multiplied by the reciprocal of 2, that's 1 over 2. Multiply the numerators out, multiply the denominators out. So you'll have to get comfortable with doing that factoring. Okay, so that was one of the harder parts, so let's continue here. Recall what sine looks like. So our options are, this could be sine or this could be cos. Remember that sine kind of looks like this, right? And has a period of 2 pi and all this kind of stuff. Plus 1 minus 1, the horizontal axis is at 0. And now let's pick from this and say, what is my a, my b, my c, and my d value? My a is 3, my b is 2, my c is pi over 4. Remember how the formula works. It's minus c, so I don't have to say minus pi over 4. I need to put positive pi over 4. And my d is a positive 2. So just a quick word about the order for our transformations. The usual rule for transformations is to do the left, right, and the up, down, those translations, to do those last, to do anything that involves multiplication first, and then to do the addition subtraction last. We're actually going to switch that around for these sinusoidal, for the sine and cos graphing. It makes things a lot easier if you actually start with your d value. So I'm going to do the order I'm going to do today is DACB. DACB. I'm not sure if you got a quick mnemonic. I'm not sure if it makes too much of a difference to have to memorize those letters, but I think as we walk through it, you're going to see it makes some sense. So the first thing is our D is going to go up to 2. So I'm going to put a 2 here, and my normal sign starts at, if I just go back over here, my normal sign, the D value is 0. And I have this horizontal central axis at y equals 0. But you'll see if I put this up to 2, then this axis is along 2. So in back to my Word document, when I put this d value at 2, I'm going to think, okay, this is my horizontal central axis. Okay, so horizontal central axis. So that's all we've done in this step. And I'm separating all the steps into different places on paper, but really this would be all in one place. You wouldn't have to draw 4 sketches. In fact, I'm kind of overdoing it. It's kind of overkill. So really the first thing I have to do is do this again. So here's my +2. Okay, so that's my horizontal, and so the sine function is going to be going like that. Well, how much higher does it get? What is my amplitude? My amplitude, again, is the absolute value of A, and in our question, what was that? It was equal to 3, wasn't it? So in other words, it's going to go 3 higher, up to 5. It's going to go 3 lower, down to -1. Okay, so again, I can put quick little lines here. So my entire graph is going to be inside, it's going to be going kind of like that. The only thing I have to worry about now, I could be pretty well done right now, except for my my phase shift, how much I'm moving it right or left, and how the period changes, how the horizontal compression is. But I got most of the vertical stuff figured out already. So the phase shift in this question is what was it? It was pi over 4, and it was pi over 4 to the right. So sine starts at this horizontal axis and goes up, right? So this is the horizontal axis. So it's going to start at my, again, I got to put the 2 here. It goes up to 5, goes down to -1. So instead of starting on this axis, it's going to be pi over 4 to the right. So I'll make this pi over 4, and I'm going to be starting here, okay? And then I will be going and making that nice curve. I'm not quite sure exactly how to scale my x-axis, so I got to be a little bit careful about did I do a good space for the pi over 4. Let's consider now the last step, which is the period. So my period in this case is not the same as b, but the period is equal to 2 pi divided by b. And in our question, b is 2, so 2 pi divided by b divided by 2 is equal to pi. Okay, so my period is pi. So in other words, I'll start at pi over 4. See if that's pi over 4, that's pi over 2. I'll just try to make nice even steps. That would be pi. 1, 2, 3, and I guess that would be 2 pi. Okay, so if my period is pi, if I hit pi over 4 to begin with, the next place would be at another pi over, so it would be at this spot, which is 5 pi over 4. So my first one was at, again, I got to put these ones in here. I guess this was 2, this was 5, this one was -1. So this was my first place, and now pi away, I'll be back at the same place in the rotation. Okay, so I need to put my 5 main points in the sine cos system. So you remember, so this is, okay, that's one full period. So when I think of it, along this axis, I will have to have, right, 1, 2, 3, 4, 5 key spots. Okay, this is at the horizontal axis, this is at the maximum back of the axis, this is the minimum, and this is back of the axis. So if I've got 5 main points, this would be equal to 4 intervals, 4 spaces in between. So right, this would be, if we count spaces, it would be 1, 2, 3, 4, 4 intervals. Okay, so I have to take my period and divide by 4. So each interval is equal to pi period over 4, and the period in this case actually is pi, isn't it? So pi over 4. So each one of my spaces is going to be pi over 4 apart. So my jumps will be jumps of pi over 4. So it is kind of, this question does work out kind of nicely, isn't it? So I start here, that would be my second point, back down to here, down to my minimum, which is over here, and then back up again. So now I'm ready to make my sketch. Okay, and then I have my nice shape here. So that's really enough to sketch it. We could actually say if we keep doing this pattern, it would actually cross here at -1. Right? We could actually draw that in. Oh, yes, it would be at the minimum here and start coming up again. And we could even draw more because it is a pretty straightforward one. Go up here and then back down again and back down. So we could draw it longer. I think I got that right. So list the 5 main points in either the sine cos pattern. If you drew your dashed lines in here on a soft pencil, I would just have to say erase those lines. Okay, erase all lines except your graph. And also put arrows in. Okay. The only exception for the arrows, if they said the graph should be only over a certain domain, and then you would put a nice dot showing where the edge of the graph is. Let's take a look at this summary here of sketching these things. The central axis, now in our case it was, I think it was y equals 2, but where does that come from? That is D. The central axis is going to be D. So whether it's positive or negative, that's where it'll be. So if we have y is equal to, I'll just write it out one more time, the A multiplied by the sine of B left parentheses x minus c plus D. Okay, if that's it, your central axis is at D, or I'll even say y is equal to D. The amplitude is equal to the absolute value of A, and so this will help you figure out your maximum and your minimum. Your maximum will be the central axis plus the absolute value of A. Right, so if you have here is your sine function, here is your central axis, that will be at D, right? So D plus A will give you your maximum, D minus, I should say D plus the absolute value of A will give you your maximums, D minus the absolute value of A will give you your minimums. And so over here D minus the absolute value of A will give you your minimum. So your period is equal to 2 pi divided by B. The phase shift is what C is, or how much it goes left and right, and your range is typically, range, remember, is all the y values that you can have is going to be all real numbers. So you could say y is a member of all real numbers, or you could put it in this form here. You could say from negative infinity to positive infinity. Okay, so this is a good one to know, that graph here. Alright, so let's try a few more examples. Tell you what, how about I'll do this one and then I'll pause and see if you can take care of the next one on your own, and then you can look at mine to see how it worked. Okay, so we should start looking at, first of all, what is what's A, B, C, and D. So A in this case is going to be equal to -3. B is already factored out, so it's kind of a nice one. B is going to be equal to pi over 2. C is equal to 1, and D is equal to -2. So my line the horizontal central axis will be at -2, and my amplitude, the absolute value of my amplitude is 3, so the highest anything will go is up to 1, and the lowest it will go would be -5. Okay, my first point will not actually be at the origin here. It's going to be a shift over of whatever C is in this case, a shift over of 1. So I'll put my 1 right here. So this will be where my first spot will be, right there where it's equal to 1. My period, so looking at the B value, if the period is equal to 2 pi over B, and that's pi over 2, dividing by pi over 2 is the same thing as 2 pi multiplied by the reciprocal 2 over pi. So instead of dividing by pi over 2, I multiply by the reciprocal, and then you see how my pi's are going to cancel out, and I'm going to get 4. So this is equal to 4. So if I started at 1, the next place that I'm going to be at the same location that I've done a whole period will be over at 1 plus 4 is 5. 1, 2, 3, 4, 5. So here's where I'll be again. 2, 3, 4. Okay, so if my period is 4, then my intervals will be at the full period divided by 4, which is equal to 1. So at every 1 number, an interval of 1, I'll be changing. Now I just got to take a look at my sine pattern. So normally sine has this kind of a pattern. But since my A is negative, I'm going to have a reflection. So after the reflection, it's going to be looking like this, won't it? So instead of going up to begin with, I'll be going downwards to begin with. So instead of going from here up, okay, I'll be going from here downwards. So I'll go here, down, and then back. Now be careful, avoid thinking about this line. You want to hit our maximum. So you want to go up to the maximum, back down again, right? So now we can sketch this in, and we get, trying to do this well here. So something like that. I don't think I did great right there. Get my eraser out. Oh my goodness. Okay, undo that erase. We'll keep that in there. So I'm a little messy. We'll live with it. Blah, 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 blah. See if we can get things to work here. Come on. All right. So we'll put the arrow at the end. How are we doing? Come on. Alright, so we got that example done. I don't think it's so bad. Let's see. I'm going to give you some time to see if you can get this one done on your own, and then I will show you my answer for it. Alright, so hopefully you got something done there. Let's try this out. My A value is going to be equal to 4. My B value is going to be equal to 2. My C value is going to be equal to negative pi over 4. And my D value will be equal to 3. So first of all, I'm going to say, okay, I will start 3 up. That will be my central axis. And my maximum will be 3 plus the absolute value of A. So I'll go up to 7. And I will go down to negative 1. My first point will be, since the C is shifting over to a negative pi over 4, so I will shift over to the left, negative pi over 4. And remember, my coast pattern is that the starts at 1 and works downwards, doesn't it, right? So instead of having my start at the maximum at this axis, I'll shift left pi over 4, so I'll put a little pi over 4 here, and I'll be starting over there. Okay, the last one is my period. The period is equal to 2 pi over 2. So it's going to be equal to pi. And so our intervals are going to be equal to, my 4 intervals are going to be each pi over 4. So if I'm starting at my maximum here at pi over 4, my next jump of pi over 4 will take me to the axis, and my next jump at positive pi over 4 will take me to my minimum. You know what, maybe I'll get some red involved here just so that it shows up over my green, because I have to write it right there, right where negative 1 hits that spot. At my next interval, I'll be up here, and then I'll be back up here again. And so labeling those in green, I'm jumping by pi over 4, so this is pi over 2, and this is 3 pi over 4. So my graph going to look something like that. Okay, so at any point along the way as well, you can go and if you get stuck and you get frustrated, or if you want to check your answer out, you can throw it into either Desmos or any other kind of graphing calculator. That's just fair. And here's your homework. It's page 250. It's 1, 2, and 3. So I hope you do well on that. Thanks.